In the last class, we were discussing certain fundamental results like triangle inequality in real analysis, and we used some proof techniques like the method of contradiction, mathematical induction to derive certain results in real analysis. Apart from that, we introduced a few functions like the absolute value function, Dirichlet function, etc. Based on triangle inequality, we would like to now solve a few problems, again using the properties of the absolute value function. So today's session will be actually a problem solving session. Our first question is the following. Using triangle inequality, show that the first question, modulus of a minus b is less than or equal to modulus of a plus modulus of b. And the second question is the following. Modulus of mod A minus mod B is less than or equal to modulus of A minus B. These are the two problems that we want to solve now. So just recall what triangle inequality actually states. Given A, B real numbers, by triangle inequality, we have modulus of A plus B less than or equal to modulus of A plus modulus of B. Replace to solve the first problem, replace B by minus B in triangle inequality. So we get modulus of A plus minus B less than or equal to modulus of A plus modulus of minus B. But modulus of A plus minus B is nothing but modulus of A minus B, and we get this is to be less than mod A plus mod B, because modulus of minus B and modulus of B are exactly the same. So we proved the first problem without much difficulty. Now we are moving towards the second problem. In the second problem, we have to show something a little bit different. So in second problem states that the difference between absolute values of two numbers is going to be less than or equal to the difference of two numbers taken and then absolute value taken. So this can be actually visualized using this example. This is for problem B. Suppose that we have A equal to 1, 2 here. This is A, and suppose that B equal to minus 1. So what is the difference between this A and B? Modulus of A minus B is going to be 2 minus minus 1. That's going to be equal to 3, and modulus will not make any difference because it's positive already. Now, what about modulus of A? Modulus of A is 2. What about modulus of B? It's 1. What is the difference between these two? The difference between these two is 2 minus 1, that's 1. Therefore, modulus of mod A minus mod B is 1. So in this case, it's less. It's not going to be the case always. So what we can claim is the difference of absolute values is going to be less than or equal to the difference taken and then the absolute value. The verification of this identity is a little bit tricky, but not very difficult. So for verifying this, we will write A is equal to A minus B plus B. So by triangle inequality, we have mod A equal to A minus B plus B. Using triangle inequality on A minus B and B, we get this to be less than or equal to A minus B plus mod B. If we take mod B to the left side, or otherwise we subtract mod B from both sides, we get modulus of A is mod B less than or equal to modulus of A minus B. So we are going to do exactly the same thing on B also. b equal to b minus a plus b. Again going to apply triangle inequality. Modulus of b minus a plus b less than or equal to pi. Here we are using triangle inequality. Here again we are going to use triangle inequality. This is b minus a plus mod b. Sorry, there is a mistake here. This is not. This is minus a. This is minus a. That's a mistake. So b minus a plus a. Now we move this modulus of a to the left side, or we subtract modulus of a from both sides. We will get modulus of b minus modulus of a equal to less than or equal to modulus of b minus a. But this is nothing but minus of mod a minus mod b less than or equal to b minus a. So we are in a kind of situation, we have two inequalities here. This is the first inequality, this is the second inequality. The first inequality states that, for example, first inequality says something like this: x less than or equal to modulus of c. And the second inequality says that the negative of that, that is minus x less than or equal to modulus of c. But we know that modulus of x is going to be either x or minus x, because if x is non-negative, modulus of x is going to be equal to x. If x is negative, modulus of x is going to be equal to minus x. Therefore, x is less than or equal to mod c, minus x is also less than or equal to mod c. Therefore, mod x, these two together implies that modulus of x is less than or equal to mod c. Here actually modulus of c is not very necessary. If we take x less than or equal to some say c, or x less than or equal to y, and minus x less than or equal to y, then by the definition of absolute value, modulus of x is going to be less than or equal to y. We put the modulus here just to compare with the whatever we have in our hand. So using this observation, that is x less than or equal to mod c and minus x less than or equal to mod c implies mod x less than or equal to c. We can now write in the place of x we have modulus of a minus modulus of b. Therefore, modulus of mod a minus mod b less than or equal to modulus of, in the place of mod c we have mod a minus b, mod a minus b. Thus, we have verified the second identity also using triangle inequality. We proved the triangle inequality for two numbers a and b, and the statement was that absolute value of a plus b, that is modulus of a plus b, is less than or equal to modulus of a plus modulus of b. Now, in the next question, we will try to see a general version of the triangle inequality. The problem is the following. Let a1, a2, etc. an are all real numbers, n greater than or equal to 2. Then the question is to show that absolute value of less than or equal to a1 plus etc. plus an. Therefore, if we have three numbers a1, a2, a3, what we are claiming is absolute value of a1 plus a2 plus a3 is less than or equal to absolute value of a1 plus absolute value of a2 plus absolute value of a3. We are going to prove this using triangle inequality and then induction. So what does triangle inequality say? By triangle inequality, we have modulus of a1 plus a2 less than or equal to modulus of a1 plus modulus of a2. Therefore, when we have two numbers, this inequality is true. Now, suppose that the inequality is true, we are going to use mathematical induction. Suppose that the inequality is true for n minus 1 numbers. Suppose modulus of a1 plus etc. plus an minus 1 less than or equal to modulus of a1 plus etc. plus modulus of an minus 1. Now we have to show that assuming this modulus of a1 plus etc. modulus of an less than or equal to mod a1 plus etc. plus mod an. This is what we have to show. So we already told that we are going to use induction here. Therefore, modulus of a1 plus a2 plus etc. plus an minus 1 plus an, we will split it like this. This is equal to modulus of a1 plus etc. Plus an minus 1, we group them together, plus an. Now, see this a1 plus a2 plus etc. an minus 1 as a single number and an as the second number. Therefore, we have one number here. This is of the form a and this is of the form b. Therefore, this is basically of the form modulus of a plus b. And by triangle inequality, this is nothing but modulus of a1 plus etc. plus a n minus 1 plus modulus of an. Now, by our assumption, we have already taken that a1 plus a2 plus etc. an minus 1 is less than or equal to mod a1 plus etc. mod an minus 1. So if we split it, then we get this to be less than or equal to the first part, mod a1 plus etc. plus mod an minus 1, and we write the last an exactly as it is. So we verified the general statement. Modulus of a1 plus a2 plus etc. an minus 1 plus an is less than or equal to mod a1 plus etc. mod an plus 1 plus modulus of an. So the general version of triangle inequality is completely verified. Therefore, triangle inequality is true not just for two numbers. We can extend it to any finitely many numbers.